Hello everyone. This video I'll explain a question about rate law, but now it's not too simple of a question, right? It's we have to solve it, okay? And however, the core understanding is still there, okay? So now again, what's this core understanding we're talking about? Such as for this question, it's given us four different trails of data. So I'm just gonna label them 1, 2, 3, 4. Okay, so we have four sets of experimental data. It's asking us to write out the rate law for this reaction. So then, of course, we'll have to know, right, first thing first, what's the rate law? Okay, so the rate law should equals to generic form will be K rate constant multiply concentration of the first reactant raised to power. I'll use X, Y, and Z. You can use any three letters. It works. Okay, just represents variables. Multiply concentration of the second reactant raised to the power of Y. Multiply concentration of the third reactant raised to the power of Z. Okay, so this is the rate law. They go, oh, is that it? Okay, so generic form, that's what it is. But since we do have the detailed experimental data, and we can solve them. Okay, so then therefore our goal is to figure out what's K and what are these X, Y, and Z values. Basically, we're supposed to look for or figure out what's the reaction order with respect of each reactant, which are the X, Y, and Z's. And also, we need to find out what's this K value, which is the rate constant, also include its unit. Okay, so now this is the things we need to do. Then let's see how we're gonna do it. Okay, so since we do have, right, we have each individual trial's information, which means we do have the concentration of each reactant and its initial rate. So you can imagine, right, we have all of this information. It's already given. Okay, and of course we don't have the things we are looking for. These are the things we're looking for, right? Okay, so now that's the idea. So then therefore, right? Yes, we have many variables, but it's okay. We can solve one at a time. Okay, so then therefore first just say I want to start from solving X, the reaction order with respect of the first reactant, the permanganate ion, right? Okay, so you wanted to solve for that. Okay, so then the goal is mathematical wise, if I can find two other trials, okay, to keep the other two concentration the same. Okay, so my goal is to find two trials and to keep those concentrations same and consistent. Okay, so then you can imagine later when I use mathematical tools to solve the problem, that's going to be right easy. Okay, so then if this is goal, which two trials can serve the purpose, which means the concentration of those two actually the same, right? That's very obvious right over here. Okay, so first two trials will serve the purpose because these two concentrations the same. So then therefore we're going to use trial 1 and 2 to help us solve X, which is, right, the reaction rate, the reaction order with respect of the first reactant is something we want to solve for. The other two are going to keep consistent, keep the same. Okay, so now how we can further actually execute the plan. I'm gonna work on this. Okay, so now of course for the first reaction or first trial or second trial, I'm gonna start with the second trial. I'm gonna explain that why. Okay, so based on trial 2, according to rate law, we can write out such info, right? Okay, so the rate based on second trial should equals to K multiply Mn. Oh, I'm just gonna quickly write this. Okay, multiply H2C2O4 raised to the power I multiply. This is all the information should come from the second trial. Okay, so now since we do have the actual numbers, let's plug them in. So that'll be 8 times 10 to the negative 4 equals to K multiply 2 times 10 to the negative 3 raised to X multiply 1 times 10 to the negative 3 raised to Y multiply Y times raised to the power of Z. Okay, so this is based on trial 2. You can imagine I can do something very similar based on trial 1. Instead of just rewriting the whole expression, instead of this, everything I will just have 1. Now I'm just going to already plug in the info based on the first trial. Okay, so now let's write that out. That will be 2 multiply times power negative 4 equals to k multiply 1 times 10 to the negative 3x multiply 1 times 10 to the negative 3y multiply y 1 raised to power z. Okay, so now I have these two equations. Again, we want to solve this, right? Okay, so then the way to solve it, right, using math is that we're going to use two equations and divide them. Okay, so I'll say this is equation B, this is equation A. I'm going to use B divided by A. Then you go, can I use A divided by B? Yes, for sure. Okay, math-wise, doesn't matter which way you do it, as long as you, right, your information is consistent, you're doing the math correctly. The reason why I want to do it B divided by A, personally, I like to deal with a number bigger than 1, so math-wise, it's easier to handle. So then, therefore, I'm using the larger value and putting it on the numerator, okay? And the smaller one, put it on the denominator, okay? And of course, when we're dividing equations, right? Whatever on the left side, dividing whatever on the right side, we'll be dividing them, okay? I'm going to copy paste over here. Okay. Let me just do this real quick. Okay. Okay, so come to this point. Now it's math. Okay, so now let's cancel things out. That cancels out on the left side. I have 4 over here. That cancels out. Again, then you go, oh, look at this. This is convenient. They all cancels out over here. Then I have to say it's supposed to be working out like that because remember, the reason why we keep the first two trials is to serve this purpose, right? Have those information got canceled out. Okay, very good. So now that worked out. So on the right side, I'll just have this 2 times 10 to the power negative 3 raised to the power x, 1 times 2 negative 3 raised to the power x. Okay, so then I have that. Okay, so according to math, we know this, right, can work out. So then I have this. Then therefore, on the right side, I just have 2 raised to the power x. This is very simple. We can see x equals to 2. Okay, so now we figure out the first direction order with respect of the first direction order is 2. Okay, so now I believe we can work on other ones. So in order to solve y, what's the goal? Right, now we need to let me clear here real quick. Okay, so we want to solve for the second one right over here. Let me use a different color. I want to solve this, right? Okay, so what's the goal? To find out two trials of those two. We want them to have the same, right? Okay, so which two trials will be able to help us to do that job is this two, right? You see that's the same, and they can get canceled out. Okay, so now we want to keep the other two same. So then we know we can use trial 1 and 3. Okay, so now I'm just gonna quickly write out, I'm just gonna jump to this step. Okay, so I saw 3 and 2. I'll put the rate on the left side. I'm gonna use a bigger value on the numerator. Like I said, you can use the other one. Okay, so the other way around, totally fine. Will come out the same value anyway. On the right side, now I have 2, of course, k is there. 2 multiply 10 to the power negative 3. Actually, at this moment, we don't really have to write x anymore. We already know it's 2. I'm going to write 2. Okay, so that's it. And multiply 1 times 10 to the power negative 3 raised to the power y. 1 raised to the power z. On the denominator is 2 times 10 to the power negative 3. Again, we already know it's 2. So 1 times 10 to the power 3 to the y is 1 to the z. Okay, so come to this point, math, right? Okay, that cancels out, that cancels out, that cancels out. That's how it's supposed to work out. That's the whole point. On the left side, we know that y equals to 2. Over here, we can I'm sorry, I think I have the number. This is not 1, this is 2. Okay, so let me fix that. So this is 2. Okay, so then over here is 1 times 10 to the 3, 2 times 10 to the 3 raised to the power y, and this 2 equals to 1/2 raised to the power of, hold on. Yeah, it's the other one. It's 3 is 2. I was like, that didn't work out right. I'm sorry, let me fix that. This is 2, this is 1, right? Where this is also something when you work out, make sure you keep track which equation you put on numerator, right? This is trial 3 info. This is trial 2 info. So don't get confused like what we did earlier. So let me fix that. So this is supposed to be 2. This is 1. Now the number will look correct, right? So that's 2 raised to the power of 1. Okay, so now we'll see y equals to 1. Okay, so with respect of the second reactant, the reaction order, this y actually equals to 1. Okay, so that's how you solve the second one. Okay, same idea. If we know how to do the first two, I believe we can figure out how to solve z. Okay, so how to solve z? The idea we have been using is now what? We're gonna find out two trials. They're gonna keep the first two reactant consistent, but just as a heads up at this point, since we already figured out what's x value, what's y value, essentially, actually, if there's no two trials, serves the purpose in terms of having the two trials have the same concentration based off the first two reactants, that'll still be okay because we already have the reaction order anyway. Okay, so just to keep that in mind. But for our question, it's nice because we can find, okay, so in order to keep the first two reactant have the same concentration, okay, we can see trial. Oh, earlier I meant 2 and 3. Okay, I'm sorry. Okay, so trial 3 and 4, trial 3 and 4, right, can serve the purpose. Okay, so that's that. So now let's try to work on this real quick. I'm gonna copy paste my data over so we can look at it and plug in. Don't make mistakes, right? Okay, so I'm gonna put it over here. Okay, here we go. Okay, so now we're gonna focus on this 2, 3, and 4. I'm gonna put 12. Let's do 12, 4 on top, 12, 3 info on the denominator. Okay, so we're gonna put the rate on the left side, and like we did earlier, put everything else on the numerator. So that'll be 2 times 10 to the power negative 3. Like I said, I'm already trying to show you, right, the whole idea. You already have the reaction order solved, and then just have it written out already. So either way, right, this can be solved without the same concentration or not. So that's 2 multiply 2 times 10 to the power negative 3, 1. That's 1 raised to the power of z. Okay, come to this point, you see, again, the whole idea, the first two should be able to cancel out. Like I said, once we find 2, really, they cancel right now, it's fine because they're actual numbers. We know exactly what it is. Okay, so that's that. Now on the left side equals to 1. On the right side, we have 2 raised to the power of z. This is another easy math. We know any number raised to a certain power, we need the result equals to 1, so this power needs to equals to 0. Okay, so now we'll find out z equals to 0. Okay, so now at this point, we can rewrite our rate law because we find out many informations. So the rate equals to k multiply NO4 raised to the power 2 multiply H2C2O4 raised to the power 1 multiply proton raised to the power of 0. Okay, so of course we can further simplify this. We know any power raised to 0, that just equals to 1. So I have this as a rate law. And now the last part of this question, we need to figure out what K is. So you can use any trial. Okay, so I'm going to use trial 1 just to plug in the information. Okay, so I'm going to use trial 1, and then let's put that in. So it's 2 times 10 to the power negative 4. At this point, we'll need to bring units because we need to solve K, including its units. So K, concentration is 1. We're looking at the first trial. 1 times 10 to the power negative 3. Second order, 1 times 10 to the power of negative 3. First order, but remember we want to bring their units. Okay, so that's it. Now let's isolate K and put everything else on the other side. So I'll have this over here and divide this. Okay, so I also want to solve it real quick just so we see. The numerator is good. It's easy. Denominator, the 2 needs to distribute to the number and exponent, so that will be 1 times 10 to the power negative 6 molar squared, multiply 1 times 10 to the power negative 3 molar. Right? Okay, so now you see this cancels out. Of course, when you have exponents, you're gonna do add, right? Because that's negative 9. It's on the denominator, flip back up, that'll be positive 9. Okay, so then positive 9 plus the negative 4, that becomes positive 5. So K will equal to 2 times 10 to the power of 5, positive 5. Units will be molar, negative 2 multiply second, negative 1, and then the rest of the rate law expression, MnO4 raised to the power of 2 multiply H2C2O4 raised to the power of 1. Okay, so now finally we finish off this question. Okay, so this is a rate law question based on trials, experimental data, and now we are able to find out the reaction order with respect of each reactant and the rate constant. And actually for this type of question, I can also have a follow-up question with the overall reaction order. So how do we do that? Well, reaction order is simply adding up all the reaction orders. For this question is 2 plus 1. We had a 0. So now adds up equals to 3. Okay, so then this is a rate law calculation question. Okay, so once we practice enough, then you'll see this type of question actually not hard at all. It's all based on the core understanding, and then we got this. Okay, and then thank you for listening.